Welcome to Frontline Systems webinar on Solver SDK Platform. Solver SDK Platform is a powerful, comprehensive software development kit that enables you to embed optimization or simulation in your application. What we'll explore today are the Solver SDK products and how you can gain a payoff by using our tools. Together, we'll review various examples developed in Solver SDK Platform. The optimization and Monte Carlo simulation techniques are widely used across many industries: energy and utilities, manufacturing, transportation, financial services, and marketing and sales, for example. You can use Solver SDK to bring the optimization and simulation power to your application. Solver SDK Platform can be used in any Windows or Linux application. You can deploy your SDK-based application in different ways: on a desktop, a corporate server, a web server, or you could deploy it where Solver SDK is on one server and your application is on another. In order to build an optimization or simulation model, you can use the object-oriented API in the supported languages where the APIs are available. Solver SDK Platform supports programming languages such as C, C++, C#, VB6, VB.NET, Java, R, and MATLAB. The SDK also exposes a standards-based web service API, enabling you to create models in PHP and JavaScript. You can create a zero-footprint application that defines a model on a web page for use in a browser or mobile phone and solves the model using the web service. Furthermore, Solver SDK Platform allows you to load and solve Excel workbook models. This creates a bridge between your business analysts and developers. Let's look at one example. This is standard example 2, a complete definition of a model in code in the syntax of C#. There is no Excel workbook. Without going into details, we are setting up a linear programming problem. Initially, we define the problem as a maximization type with a certain number of variables and constraints. Because this is a linear programming problem, we define the rest of the model using these double matrix objects. Then, at line 140, we specify upper bounds on the constraints. This array, which holds the upper bounds of the constraints' right-hand side values. At line 142, we make the variables non-negative. In lines 144 through 145, we make the variables integer. And at line 147, by calling problem.solver.optimize, we optimize the problem. If you have a portfolio accounting application, for example, and now you want to add an optimization model to your application, like a portfolio optimization model, you need a solver and a model. You can create and define the model in different ways. One is you can do it in code in your choice of programming language, or you can do it in Excel using Excel formulas. Both ways work. The solver is in SDK. Solver SDK is capable of accepting the definition of a model both through calls to the object-oriented API in code, or it can just load an Excel workbook and use that model. It then sends the results back to the application. So, with Solver SDK, you can develop models in Excel workbooks, and you can deploy Excel models to an on-premise or cloud server. You can get the data from some external source, a database, or your user input, for example. Let's look at one example. We are going to load the product mix Excel workbook example change some of the input parameters, and solve it. In this problem, a company manufactures TVs, stereos, and speakers using a common parts inventory. Parts are in limited supply, and the goal is to determine the most profitable mix of products to build. Here is the code. As you can see, a Windows Phone application is used and a directive using Solver platform is added. Further down, in line 378, prop.load loads the active spreadsheet inside the Excel model, then calling prop.solver.optimize solves the model. These additional lines display the solution status along with the final objective and variable values with multiple message boxes. Let's run this and see the results. As you can see in this form, we give the user the choice to change the input values at runtime. Here we expose the objective coefficients. Let me show you that this is done using the SciInput function. Here in cell A28, SciInput says that D17 through F17 are changeable at runtime and represents them by an input data object. Therefore, now we can change the price of each TV from 75 to 85 and hit optimize. Here are the results. You can also automate the product mix optimization workbook with VBA using the object-oriented API in Excel products such as Premium Solver Pro or Platform. You just need to add 2 lines of code for the active worksheet. First, create an instance of the problem using dimprop as new problem, then to perform the optimization, call prop.solver.optimize. As you can see, Frontline's Solver SDK Platform object-oriented API closely resembles the API in Excel. In addition, you can have applications for mobile devices where you're solving an optimization or running a simulation model as part of your application. You can create models in code. You can send the model in XML format, solve it using on-premise or cloud server, and receive the solutions from the SDK in XML format. Let's look at an example of JavaScript code. You can find these examples in SDK folder under Solver Server. Let's double-click Solver Server and then double-click Client and then Examples, JavaScript, and Example 2. Here is the source code. This is the same linear model we first reviewed, Example 2. The code is very similar. Instead of C#, now we are in JavaScript syntax.